Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to start with a discussion of slave error in APB. Basically, a slave error is signaled when an APB slave cannot complete the transaction as expected. This could be due to accessing an invalid or unimplemented address, or an unsupported operation like trying to write to read only register, and internal slave faults, example for timeout, hardware failure. So in this particular cases we are going to get slave error. Now in APB3 version and APB4 version, slave error is indicated using P slave error signal. If your P slave error is equal to 1, then that means the master will come to know that there is an error occurred, and if your P slave error is equal to 0, then it is a successful transaction. So it is driven by the slave. P slave error is driven by the slave. It becomes valid when your P ready is equal to 1 and transfer is finishing. APB transfer with error flow. Now here, if master initiates a transfer by asserting P select, P enable and optionally P write, slave responds with P ready. If it is equal to 1, then the transaction is completed, and if your P slave error is also equal to 1, then it means there is an error. Then the master must check P slave error to know if the transfer succeeded or failed. For example, let's say if this is your master and this is your slave. Okay, now we are going to perform a write operation. That means the data is being transferred from master to slave. Now in the T1 to T2 phase, it is an address phase. Why it is an address phase? Because your P enable is equal to 0, it is an address phase, and your P write is equal to 1, so that data is being transferred from master to slave, and the slave is being selected, P select. Now your P enable was equal to 0 and you are sending the data from address phase only, the master is sending the data. Now your P ready was equal to 0. Whenever you have entered into data phase, your P enable is equal to 1, but your P ready is equal to still 0. That means it is an extended transfer and the slave is not ready for any kind of transfer. Now whenever your P ready is equal to 1, the slave error is also made to 1 by the slave. That means it is a error transaction. What may be the reasons of this P slave error? That can be a wrong address, or it may be a address which is pointing to a read-only memory, or it may be a wrong address, or it have been selected a wrong slave, or it may be invalid data. So for the particular reasons, your P slave error may be asserted to 1 by your slave, and this P slave error should be asserted to 1 with your P ready signal. If your P ready is equal to 1 and P slave error is equal to 1, then only it will be sampled by the master. If your P ready is equal to 0 and if your P slave error was made to 1, then that particular P slave error is not sampled by the master. So this is how we are going to decide a write transfer with an error. Now let us try to understand a read transfer with an error. So read transfer can also complete with an error response indicating that there is no valid read data available. For example, whenever in the T1 to T2 cycle your P enable was equal to 0, then that is an address phase, and in the T2 to T3 cycle your P enable was equal to 1, that is it is a data phase. Now in the address phase, the master is providing the address, and P write is equal to 0, that means it is a read operation, and P select is equal to 1, that means a slave is being selected, and you are not going to get any data on the data bus in the address space, and your P ready was equal to unknown, and there is no slave error also. Now whenever the master has entered into data phase, we don't have any data still available here. Because your P ready was equal to 0. Since your period was equal to 0, we don't have any data available on the PR data bus. Now whenever your period was equal to 1, there is still no data available at all, and still there is no valid data available. So if the slave wants to tell the master that there is no valid data available, then it is going to give you the P slave error. That means there is no valid data available. So this is how we are going to indicate that there is no valid read data available. The slave is going to tell the master by asserting this P slave error and your P ready is equal to 1. Now let us try to understand the operation of how we are going to happen it, whether it may be a write operation or read operation with the help of this state diagram. Initially, your master will be an idle state, and whenever your p select is equal to 0, we are going to stay in the idle state only. Now, so initially the master will be in the idle state and your p select will be equal to 0. That means no slave has been selected, and if there is no transfer, we are going to stay in the same state. But if your transfer is equal to 1, then your master is going to idle state to a state which is known as setup phase. Okay, this setup phase, you can also say it as an address phase. So in the case of setup phase, your master is going to assert your p select signal to 1 and p enable is equal to 0. Whenever your p enable is equal to 0 and p select is equal to 1, it is an address phase. It is also called as address phase, or it is also called as a setup phase, it is also called as a setup phase. And from the setup phase, we are going to next phase, which is known as access phase. Now, in the case of your access phase, your p enable is equal to 1. If your p enable is equal to 1, it is also called as an access phase, or it is also called it as a data phase. Now, in this particular access phase, your p select is equal to 1 and your p enable is equal to 1. And if your p ready is equal to 0, we are going to stay in the same phase. Until and unless your p ready is equal to 1, you are going to stay in the same phase. And if your p ready is equal to 1 and there is no further transfer required, we are going to simply idle state. But if your p ready is equal to 1 and there is need of some other transfer, then we are going to a state which is known as setup phase again. So this is how we are going to perform any transfer. It may be a write transfer or read transfer in APB protocol. Simple. This particular FSM we are going to implement in our Verilog coding, and we are going to see how it is going to work. So you can see here in the idle phase, this is the default state of the APB transfer, and in the setup phase, when a transfer is required, the interface moves into the setup state. When the appropriate select signal p select is asserted, the interface only remains in the setup state for one clock cycle and moves to the access state on the next rising edge of the clock. And the access phase, the enable signal p enable is asserted in the access state. The following signals must not change in the transition between setup and access and between the cycles in the access state. So what are the signals should not be changed during the transfer from access to setup is p address, p dot, p write, pw data only for write transactions, and p show, pa user and pw user. And exit from access state is controlled by your p ready signal by the completer. You are allowed to go to access phase whenever your p ready is low by the completer. Then the interface, if your p ready is equal to low by the completer or the slave, then the interface remains in the access phase. But if your p ready is equal to high by the slave, then the access state is exited and the bus is returned to the idle state if no transfer is required. Alternatively, the bus moves to the directly to the setup state if another transfer follows. So that is how we are going to, this is how we are going to work with our transfer APB transaction. This is how we are going to work with our APB protocol, and this FSM we are going to implement it on our coding, and we are going to see how it is going to work out. So that's all about this particular video. If you like this video, please like, share and subscribe to my YouTube channel, and from the next session we are going to start with the coding of APB implementation. Thank you for watching this video.